Okay, I'm designing ESP32 board for a circuit. Okay. What? Where am I even going? Who's EDA? God bless, I can't even think. Okay, I'm gonna have to hide my email. Hold on. Am I good? Okay. Taking heavy inspiration from this design of mine. It's called Arrow Sketch. It's like a little ESP32 board. Let's make a new one, new standard project. Let's name this brush, or brush bud, because it's like a little toothbrush timer. That's like smart. Okie dokie. Okay, we're gonna be using the same ESP32. So 3v3n. So we don't. Okay, let's just copy everything here into here. And then we can work with this. Okie doke. Alright, so we're using this. We're gonna keep this. We don't need these. Okay, we do need these. These are our push buttons for enable and reset. So we're gonna keep these. We're also gonna keep the enable. Schematic, I guess you could say. Don't need that, and I don't need that. Both I don't need. LED. Okay, let's keep the LED. Because I'm probably... You know what? No, we're not going to use the LED. Why would we need that? TFT? Nope. SD? Nope. Okay, this is our battery charger. We don't even need a battery charger. Why? Because we're not going to be using a battery charger, right? We are going to keep this USB Type-C port. Okay. And we don't need a switch. This is going to be on all the time. UART, we're going to keep the UART for programming, initially programming this device. We don't need this in BU6050 anymore. Okay, this is kind of the bare bones what we're working with. Don't need a switch. Okay, voltage regulator. Let's just get rid of everything that's not the voltage regulator. Well, everything that's not the voltage regulator. Okay. Okay. We're gonna keep this intact because we're still using UART. And yeah, okay. ESP32. Nope, nope, nope. We need IO0. We don't need any of these. Well, I need those for programming. Nope. Okay. This is for the 3v3. These are decoupling capacitors. So we're gonna keep the decoupling capacitors. Ian, we need that. Don't need that. Don't need that. Don't need that. Okay. EN IO0. So this is kind of what we're working with. Our pins right here. We have ground IO0. Yep. EN. This is the enable button. Okay, this is reset. Just saying. iTunes. I don't even use iTunes. Okay. This is our reset. This is the program pin. Alright, no, this is reset. This is program. The enable. Yeah, I mean, this is just default pulled up. Like it's just pulling up EN3v3. I have a board with these schematics that's coming in soon, and I'm gonna test it. And if it doesn't work, then I'll revisit both schematics. But for now, I'm just gonna build off of this. If someone that knows what I'm talking about is watching my stream, tell me if what I'm doing is correct, or critique me. Just help, I guess. Okay, so the power that's be going into our circuit is coming from this 3v3 flag, our net flag that's 3v3. So this is the main power line that we're going to be working with. So voltage out on here, these are going to be both connected to our 3v3. So that's right. Voltage in, it's going to come from this. Okay, I need the pull-up resistors, so I forgot these in my design. These are just going to CC1, CC2, like that. Let's see here. Let's remove these. So what this is this tells the USB port like what voltage to use. Like, say you have a charger and you plug it in, it'll tell the charger, oh hey, I want 5 volts and I want it at this current. So it's gonna get that voltage at that current from the charger. Okay, V-bus is gonna be 5 volts. I don't think I have any other 5 volt in lines. I could search. Net label, no. But 3v3, got a net label. Okay, this is not working how I want it to work. I don't think I have that sheet. Yeah, I just pulled everything from this this data sheet. So let's see. Okay, I think we have some. Yeah, it's just like how to do module. No. You know, it's okay. Let's just work with this. Okay, yada yada yada, ground, we need to connect that. Voltage in, 5 volt, again. Okay, so it's going in. Yeah, voltage out and out to here. We need our screen. 6. No, that's a charger module. This is D1306. That's our screen. There we go. Let's find a good one. I need one that's not ugly. Sorry. You know what? Let's just use this. It's color. Why is it in color? Okay, 1306, blah, blah, blah. Ground. Can I connect flags to this? These points that I can actually use? These are points that I can actually use. Okay, we're gonna run this off of 3.3 volts because it's enough to run the screen. But I don't really want to mess with 5 volts. Because if like I2C line's short, I don't even know if it'll support 5 volts. Because, well, I know it might have a voltage step down for the 2 lines. But if you don't have that, it'll just run at whatever voltage you're at or what we were working with, I'm pretty sure. Okay, that didn't even connect. Okay, now it connected. Okay, we have 3 volts here. Our 2 data lines. So I have some code. Let's see, what am I working with? This is my, no. Okay, let's see. Let's, okay, here's my code. Steal it if you want. I don't care. I just gotta make sure I'm not gonna leak my my SSID and my password. Hold on, guys. Let me blur that out really quick. Okay. Alright. Yeah, just find. Just replace these. Get rid of these. Yeah. Okay. In definitions. Either define or these are the pin definitions. Okay, I have a schematic of, wait, I don't even need that. I'll just Google it. Proceed lines 232 default. Okay, GPIO 21 for SDA, 21 for SDA. $21 for SDA. 21 SDA, and it has pull-up resistors built into the screen, so I don't need to add those. Okay, 22 for SCL. 22. Okay, 22 for SCL. These are our connections for our screen. 2v3. Alright, pretty cool, y'all. Okay. Cherry MX 1U. Okay, it'll work. Okie doke. One side is ground. The other is gonna be what was my definition? Button is 4. Okay, I need a beeper. But it's a through hole. This is the one that I used. Negative, ground, positive, beeper. Just copy this over. Beeper. Which one is this? Beeper pin is 2. IO2 right here. Sideways. Okay. Awesome. It's just a switch, but God, I can't talk. I'm so sorry, y'all. Switch, buzzer, and yeah. that's pretty much it. Okay, I'm also going to include these pads, 2.54, 1x2, just a little pin header. Looks weird. Well, I want to modify it anyways to have, oh my word, y'all. Okay, fine, it'll work. You know what, let's just use an XT30, and I can just modify it on the PCB to have through hole pins. I don't know which one's positive or negative. I'm not okay right here. Nope. What was it, dude? Okay, this will work. XT30 ground 5 volts. Does this work? Yep. Alright. 5-volt ground. Alright, I think it's ready to just be transformed into a wait, did it save? Better not have saved. Okay, good. Alright, let's turn this into a printed circuit board. Okay, let's make sure the nets that we're not using are important. Okay. Fine. Why are these highlighted? These are just letting me know. Okay, yeah, we're good. See if anybody said anything. Nope, nobody. That's okay, I don't need an audience. Okay, what font? I want to, okay, I kind of want to add a font, not gonna lie. Helvetica. Kind of like Helvetica. It's pretty like minimalistic, I don't know. Okay, let's just extract these and include them. Great. Okay. Let's turn this. This is gross. I need millimeters. Okay, this is rounded. Kind of weird. Helvetica normal is pretty alright. Okay, let's turn these. Is there a Helvetica bold? Helvetica bold oblique. You know, Helvetica looks fine. Just perfect one. Okay. Okay, I want a small footprint. So, I want to try and fit it in like this tall of a box. Okay? So, what I'm gonna do, I'm gonna draw a rectangle. We're gonna make it from this point to, why did it stop editing? It's okay, I can just drag the box to about over here, I'd say. A little bit more there. I think that's a pretty good little representation. Alright, so it's gonna be 58 by 28. Okie doke. Let's make a 58 by 28. Okay. Perfect spacing on each side from the switch. Yeah, okay, so now let's center this in the back. Should be fine. I mean, I don't need pass through for whatchamacallit, Wi-Fi. Should be fine. Okay, length is gonna be 1. 2. No. Something 1. Okay, let's go down to 1.5. Nope, 1.7. Okay, hole diameter, scope, point, 0.8. Okay, that looks perfect. We're pretty close to it. Okay, let's draw, you know what? Let's draw silk layer. Okay, is this document? This is documents. Let's go document layer. Okay, this is gonna have to go up some. So let's just go up to like 18. Perfect. Perfect, y'all. Literally perfect. And then watch, we can mirror this. Like, okay, let's make a clone of this. Make this go back up to 18. Make this go down to negative 18. Or not. Okay, let's measure the distance between these two. Okay, it's 10. Is it 10 flat? Okay, it's 10. Yeah, it is 10 flat. Gosh, I'm an idiot. So that would be negative 2.382. Like that. Not whatever else I was doing. Okay, we're gonna line this up. Sure, it's perfect. Okie dokie. Okay, this is gonna be on the bottom layer though. So it'll still line up, yeah. Same for this one. 0 overlapping. It's gonna be on the bottom. Great. Great, great, great. Okay, what are these? You okay. Alright, the beeper. Let's see on the back. How's it looking? Pretty spacious. Well, not really. Okay, we're gonna do this beeper up here. So like up here. Getting kind of close, you know what I mean? That should be fine. Ground is right there too, so let's see how this looks on the view. Okay, it's pretty good. I mean, we have a mounting screw right there, but shouldn't interfere any on the top level. Okay, and everything is just like perfectly centered. So that's pretty awesome sauce. We're gonna fit a bunch of components down here. We're gonna have a title up here, but we're gonna fit the majority of these components right here. We need to make room for our power pins. So we're gonna set these bottom layer, turn these bottom like this. Just center this. Let's hide everything again. Wait, how are you still a multi-layer? Duh. Okay. It's barely off, but it'll be fine. Okay, let's check it out now. Okay, this space is going to be completely taken up by the screen. Solder those in through the bottom. Okay, ignore this because there's not actually going to be a plug there. It's just going to be pins to wire a magnet jack. Yeah, fit some components on the back here. Maybe have some decoupling stuff up here. Or like the buttons or something, but yeah guys, it's coming together pretty good. Okay, let's add a round on the board. I think it would look a lot better. What, 2 millimeters? I think that's the sweet spot right there, the 2 millimeter rounding. Okay. You know, I'm gonna put the switches up at the top. Just have them out of the way. These on the bottom layer. Get them out of everybody's way. Just have the switch one. It's probably gonna be ugly. It's not too ugly, but it's not pretty at all. And this is gonna interfere real bad. These two. So why don't I put them over here by the ESP32? Right there. I'm getting a call from Tucker Kronk. I'm gonna end the stream. Or no, you know what? Sorry, y'all. I got a call. Somebody asked me something. Okay, these are overlapping. Fix that, put a little bit of space. Just center these above the switches. Okay, it should look pretty good. Oh yeah, that is greatness right there. We could put our voltage regulator right near the USB port as well. Pretty sure that'll fit. Well, I'm not so sure because we got to make room for this hole for our switch. So this is gonna be tough. What? Put it right there, you know. It's on the bottom layer though. Okay, refresh. Ooh, it looks kind of gross. It looks kind of gross. It'll work. Okay, we'll have our logo there. Brush bud. How did it know what I was gonna type? It's kind of weird. Kind of weird, guys. Okay. Pretty good. I'm gonna keep that like that. You know what, for these two, let's just put them top layer. Make it look, or bottom layer. Oops. So it doesn't look as ugly. See, it's kind of like burnt in. Gives it more, okay. Let's work with these capacitors and such. Alright, let's hide the document layer. It's kind of ugly a little bit. You know what? Nah. Alright, where are you going? Okay, switch 3 2 and ground. You know, you're gonna be ground. Okay, let's put. Okay. Okay. Let's see how it looks right now. Okay, we're gonna have our switch, pins. Looks kind of naked, but you're gonna have a screen right there. Let's just have our text right here, top scope layer, just about right there. Let's make it 6 millimeters. Brush, bud. Pretty nice, pretty nice, pretty nice. Okay. Pretty good, pretty good. Ooh, that's ugly font. No, that is not ugly font. It looks ugly in this render. Okay, let's get working on placing these components. Okay, this is another EN1. But you know what? Let's just line these two up. Make this about like 0.8. Okay. Only have a few more to place. Like this one. It's another EN. Yep. Whoa. Okay, switch. This is going to that switch over there. Yikes, it's a bit of a distance, but you know what? Why don't we just place this one like right here? Like that. This tile up here with that height. Boom, just center it. Yup. Yup. Alright. Yo, where is C5? Does it even matter? Oh, these are decoupling. C5 and C6 are. So these two are going next to the 3v3 as well. Because these are really important. Okay? So I think these two can go like over here. Because they're not as like important. You get me? And I can just put these titles to the left. My PCB left, my right. Okay. I think we have a little bit more room to the right, my right, to work with. That looks pretty good. I'm gonna move it just a little bit. I was right. That much. Yeah, it looks pretty good. And we could just have our two decoupling capacitors over here. So these two, okay, what is the tile height? Okay. Okay. No. One more. Where are you? IO0. Okay, you're way over here, buddy. Oh, you can just go right there, and I'll just make this 0.8. Whoop. Boom, just like that. I think our design's finished now, at least. Oh no, I have to route the things. Okay, mounting hole, mounting hole, mounting hole. Button. Screen's gonna take up all the space. The back is the most where it's most at. Voltage regulator, USB port, resistors, switches, EN, enable, and reset. Something, I don't even know. These are for like 3 volt or something. Oh, and these are decoupling capacitors for the 3 volt and the ground, or between those. Okay, let's do a copper pour the ground on both layers. Let's just copy and paste it. So it's gonna be on the bottom layer. We can just auto route. I'm lazy. Duh. It's I mean it's complex. Yes, see, it did it. It's a pretty quick design, y'all. Okay. I like to make it like a teardrop. It's like where it fillets the ending. It makes it look nicer. You can see this is before. You can see after it just kind of fills into the via or the pad or wherever it's headed. Makes it look super nice. And for the fill in right here, you know, I'm just gonna keep it because spoke direct is just fully filled, but spoke kind of like makes it thermally better, I guess. I mean, you could say that, but okay, let's do a design rule check, make sure everything looks fine. Yeah, 0 errors, perfect design, right? Probably hundreds of things I can improve on this, but I mean, it's pretty good. I mean, yeah, it's pretty awesome, y'all. Yeah, that's it for me for now. Hope y'all enjoyed my little stream or whatever. A few things. Few things I suppose I could like work on is like the antenna, like cut this off to better range, but I mean it works fine as is, I'm pretty sure. But yeah, circuit board design. I'm a little bit concerned about these traces down here, but I think it'll be fine. I think these are my programming pins. Yeah, these are my program. It's like a differential pair. That's pretty cool. The auto router knew. I think these are the TX and RX pins. Yeah, it routed them as a differential pair. Like ground VCC, but these two are like literally. I did not know it knew how to do that. Yeah, it just put those right. Nice, 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 nice. Okay, that's it. I sound like a little geek. Like, as I am a little geek, but let's see. Let's measure it. Let's see how big the board is compared to my other. Okay, can I measure? Okay, it's not gonna let me measure. Oh, it's because document layers hidden. .58 millimeters by. That is a not measure. Like 28. See how big my case design was, because I think it was bigger than 58 by 28 or whatever. 50. God, let's get out of my way. 58 by 28. Let's see what it is. Yo, I've been doing this garbage for an hour. Ugh. Not ugh. I enjoy it. I don't know. Magic wand. Oh, that's my reference I used to design the case. It's here somewhere, y'all. Trust. Trust. Where is it? Where is it? Where is it? Can I sort it by like date? Yada 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 yada. Blah 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 blah. Old brush bud. Okay, this is like the reference design I used. Where are you? Here it is. I think. Looks. Oh, it does not look like what it was. Never mind, it is. Okay. Let's see here. Okay, case width 54. Oh, yeah. 54, 58. Okay, it's perfect pretty much. I mean, it's practically the same size as my circuit board in like 32. But I mean, oh, it's like pretty much the same. But yeah, it'll be a lot thinner because it'll be on the circuit board instead of like wired all together. Yeah, guys. I hope you all enjoyed watching me do this because I kind of enjoyed it, but